Hello guys, welcome to the next lecture on the PY question series. In this lecture, we will cover area under the curve which from the integral calculus. I will cover all those questions from the GATE mathematics. Myself, Dr. Harish Garg. You can simply follow my YouTube channel where you can find the playlist of the GATE mathematics and you can find the various lectures related to the PY questions. All are with the help of the shortcut tricks. So now, before I start with this PY question series, what is the purpose of this? Your target is to double integration of the function. Now, kindly let me know, can you solve this integration? Because firstly it's a dx. Can you solve this integration? It is not an easy target for you that you can integrate this function. It means the purpose is how you can solve this integration. So the one of the best ways you can always use the change of the order of integration. What is the meaning of the change of order of integration? Instead of the dx dy, I can replace them to be the dy dx. Once you change into the dy dx, your target is to find these limits. First limit is corresponding to the y and outside limit is for the x. How you can find the limits? Then for that I will tell you that these two tips for you. First way is you can always draw the graph. Graph for what? Graph for these regions. Like these are the values of the x. I can draw the graph of x is equal to y over 2 and x is equal to root ln 3. Fine. And these are the values of the y. Y is equal to 0 here and y is equal to this. Find the coordinate of this. It will be my 2. X will be my ln of 3 and y will be my 2 ln of 3. So the graph will be here. Then you can find the feasible area. Once you can find the feasible area, you can change this dx dy here and find the limits from this region. How you can find? I will explain you with the help of one example. For example, here, can you solve this integration? Because it's a dy. It is not an easy target for you. You can solve this integration. But if I replace this function to be dx into dy, then firstly you have to integrate with respect to x, and that means this will be my constant. So that will be easy for you. So how you can solve this? You can find the feasible area. This is my y. So y is equal to ex, y is equal to e. Fine. So draw the graph of this. This is y is equal to ex. What is the y is equal to e? This is my y is equal to e. This point is my point of the intersection. When y is equal to e, x will be my 1. Then these are the coordinates of the x. X is 0, x is equal to 1. So this is the line x0 and this is the line corresponding to x is equal to 1. Fine. Now look at the feasible area. Your target is to move from ex to e. So this is a line of the ex, move from this towards e. So this is my feasible area. Once you can find the feasible area, you can write this limit. Firstly, it's a dx. So you can draw the horizontal strip. Fine. What is the value of the x at here? 0. What is the value of the x at here? This is the value of, this is the graph of y is equal to ex. So can you find the value of the x from here? It's a log of y. Fine. And outside limit is always the minimum and the maximum value of this variable. So what is the minimum value of this is 1, because x is equal to 0, y is equal to 1, and this is my e. So the outside limits are my 1 to e. Fine. Or you can say it's a log of y. Now you can integrate with respect to x. 1 over log y is my constant. I can take in it outside. So integration of x will be my here. Fine. Now what is the integration of this? You can substitute the limit log y minus 0. Now you can see this value will be cancelled out. So what is the remaining side? You can see the integration of this will be my e minus 1 is the right answer. So this is the way you can solve this question in a very simple manner. So my advice always, whenever you will see the double integration, draw this region and change the order of integration. You will get your answer in a reasonable time. So I hope you can like and subscribe my channel too. If you want to join with me, you can scan and join this barcode and we will see you on the WhatsApp group. So let's start with the PY question series. Your target is to find x into dA. Fine. and using the transformation. Whenever the word is transformation is given to you over this, you always write the Jacobian. Fine. So firstly, I can substitute the value of the x is a 2u minus 3v. Fine. Now this area will be my dx into dy. What is the reason is 0 0 1 0 0 1. So that is my here. Your target is to transform this region, so I can use the Jacobian. Fine. So how you can find the Jacobian? It's a u with respect to x, x to y. So I can say it's a x with respect to u, x with respect to v, y with respect to u, and y with respect to v. So what is the value of the x with respect to u? It's a 2 minus 3 1 1. So the determinant of this is 5. So it's an absolute value. So I can substitute here. 5 is outside. 2u minus 3v du into is the right answer. So it's a 5 is missing. U plus v doesn't need it. This is also cancelled. Right option is the right answer. Now you can see it's a double integration. Again, it is not an easy target for you that you can integrate this with respect to x. So what you can do, draw the graph. X is equal to 1 over y. What is the graph of this? It's a hyperbola. X is equal to infinity. Y is equal to 0. Y is equal to infinity. So which one is the common portion? This one is because you start from the hyperbola to infinity. So this is my reason. Then I can change this value x4 e raised to power minus x cube y from dy dx. So y, you can take the vertical step. What is the value of the y here? This is the equation of xy is equal to 1. So the value of y is 1 over x. Upside is infinity. What is the minimum value of the x? This is the minimum value of the x, 0. Maximum value will be infinity. Now you can solve it. You have to integrate with respect to y. So x4 is my constant. So it means your target is x cube into y. So make sure x cube is my constant. So it is just like say a into y. So what is the integration of this? E raised to power minus x cube y divided by minus x cube from 1 by x to here. Because integration of this will be here. Now you can substitute the limits. So x cube will be cancelled out. It's a minus of x. If I substitute infinity, it's a 0. If I substitute 1 by x, it is my minus x square. Fine. So minus minus plus, it will be my x e raised to power minus x square. Now what is the integration of this? I can multiply by 2 and divide it by 2. It will be my simple integration. So it's a half. It will be e raised to power minus x square over minus 1 from 0 to infinity. So when you substitute infinity, it's a 0. When you substitute 0, it's a 1. So the answer is half is my right answer of this problem. Look at this another one. Again the double integration. You have to firstly draw the feasible area. X is equal to 0. X is equal to 1. Y is equal to x. Y is equal to 0. So which one is a feasible area? I can choose any point here. Say 0, 4. Does it satisfy this equation? 0 less than 4 less than x. Less than x is my 0. So it doesn't satisfy. I can choose any point here. It will be my 3, 0 here. So is it satisfied? 0 less than, yes, it's satisfied. So my feasible area is here. Fine. Now I can change this integration to be double integration x plus y dy dx. So what is the limit of dy? Take the vertical step. What is the value of the y at here is 0. Value of the y at here is x. What is the minimum and maximum value of x is 0. This value is my 1. So 0 to 1. Now you can solve it with respect to y. So x is my constant. So it's a xy. It's a y square over 2 from 0 to x. If you substitute x is x square plus x square over 2. it's a 3x square over 2. So what is the integration of this? 3 over 2 outside, x square is x cube over 3 from 0 to 1. So what is the answer is 1 over 2 is my right answer of the problem. Fine. So it's a very simple. Look at this another one. Again it's a double integration. You can draw the graph. X is equal to 0, x is equal to y. So which one is the portion? I can take any point here, say 3, 0. Is it satisfied? 0, 3 less than not satisfied. If I take any point here 0, 3, 0, 3 is satisfied. So my feasible area is, this portion is my feasible area. Fine. Now what is the integration of this? Y e raised to power minus x e raised to power minus y. I can change this integration, dy dx. So firstly y, take the step on this, value of the y is my x, up value is my infinity, minimum value of the x is my 0, maximum value is the unshaded portion is infinity. I have to integrate this with respect to y. So x is my constant, e raised to power minus x is outside. What is the integration of y e raised to power minus y? Always remember, whenever there is a one polynomial term, you can write it and separate here. Find the derivative of this until it becomes a 0 and integration on this side. Derivative of this polynomial, integration of this one is a plus 1, and then you can multiply this with the positive sign, multiply this with the negative sign. So what is the right answer is minus y e raised to power minus y and minus e raised to power. Otherwise you can use the byproduct rule or islet rule. This is dx. Now I can substitute the limit. When you substitute infinity, it's a 0, and when you substitute x, it's a minus plus x e raised to power minus x minus plus e raised to power minus x into dx. So what is that? It's a x plus 1 e raised to power minus 2x. Again you can see you need an integration. Again it's a polynomial. I can write x plus 1 here and 2x this. Take the derivative until it becomes a 0. Integration of this part, e raised to power minus 2x over 4. I can multiply this with the positive sign, this with the negative sign. So e raised to power minus 2x, I can say I can take it as a common, and side is x plus 1 over minus 2 and minus 1 over 4 from 0 to. So when you substitute infinity, it's a 0. When you substitute 0, e raised to power 0 1, it will be minus half minus 1 over 4. So the answer is 3 over 4 is the right answer. Now again it's a double integration. You are unable to solve this integration here. So I can draw the graph. This is a y. So y is equal to x and y is equal to infinity. This is the y is equal to x, y is infinity. So this is my common portion. Fine. So I can change this integration. I can change this integration 1 over y e raised to power minus y over 2 from dx into dy. So I need the limit of x firstly. Take the horizontal axis. X is my 0. This is my y is equal to x. So this is my y. Outside y, what is the minimum value of the y is 0. Maximum value of the y is infinity. Now integration with respect to x, all are my constant. So when you integrate this with respect to x, what is the answer of this? It is my constant from 0 to y. So what is that? It's a y. Y will be cancelled out. So what is that? It's a e raised to power minus y over 2. Now you can see it's a very easy. You can integrate this as here from 0 to. So when you substitute infinity is a 0. When you substitute 1, it will be my here. So what is the right answer of this? 2 is the right answer of the problem. Always draw the graph of this and you will get your right answer. I hope you can like, share and comments on video as well. Okay, there is a function is defined here. The area of the image means your target is to find area of the image here. Now you can see this is a transformation. I can take u is my e raised to power x plus y, v is my e raised to power x minus y. Fine. So your target is to find this area. So firstly we can find the Jacobian. What is that? It's a u with respect to x, u with respect to y, v with respect to x, v with respect to y. So what is the answer of this? U with respect to x, e of x plus y, e of x plus y, e of x minus y, and minus of e of x minus y. So what is that? It is minus e raised to power 2x minus e raised to power 2x. It will be minus e raised to power 2x is the fine. So it means now this will be your target is to find the area of the image under the function f. So that means, so if I taken this as a u, so your target is to find this area. So I can change this area to be dx dy. You can see I have written this as upside, so it means this is du dv over, so it's a Jacobian. So what is the absolute value of this Jacobian is 2 e raised to power 2x dx dy. What are the limits? You can see the limits are given to be 0 1 0 1. Now because the limits are my constant, so I can integrate this both at the same time. This is my with respect to x, and with respect to y will be here. So what is the right answer of this? 2 will be cancelled out. It is e square minus e raised to power 0 1, 1 minus 0. So what is that? E square minus 1 is the right answer. Okay, the value of this in the first quadrant, so you can draw the graph of this. Y is equal to x square. This is a parabola. Y is equal to x square. X plus y is my here, and x is equal to 0. This is my x0. Which one is a common portion? In the first quadrant only. So this is my common area. Fine. So how you can solve this? I can, if you take as a limit of the x-axis, then you have to take the two limits, one from here, second from here. So that means you have to differentiate, you have to break from this point A. But I can simply use this as a dy dx. So what is the limit of the y? I can simply take here. So this is the graph of y is equal to x square. This is the graph of y plus x is 2. What is the value of the y here? X square. What is the value of the x here? The value of the y is 2 minus x. What is the minimum and maximum value of the x? Minimum value is 0. Can you find this coordinate? If you see the coordinates, can you find the coordinate of this? Is it a 1, 1? Yes, it is a 1, 1. Now that's over. You can solve with respect to y. So x is my constant. So this will be y square over 2, from 2 minus x to x square. Fine. Half I can take as a constant outside. So it will be 4 plus x square minus 4x minus x raised to power 4. Now you can multiply them and integrate. It's a 4x. 4x, integration of the 4x is 4x square by 2. X cube, x4 over 4. 4x square, 4x cube over 3. X raised to power 5. X raised to power 6 over here. So what is that? It's a half. It will be my 2 plus 1 over 4 minus 4 over 3 minus 1 over 6. So what is the right answer of this? It's a 8 plus 1, 9 over 4. I can take as a 6 is LCM, 8 plus 1. 8 plus 1 is 9. Fine. So 9 I can take as a common. So it's a 9 over 2. 12 is the LCM. 3 minus 2. So that will be 9 over 2 into 1 over 12. So what is that? 3, 4. So 3 divided by 8 is my right answer of the problem. Okay, look at this one. The reason is y square is equal to 4ax. Y square is equal to 2x. This is the reason of the y square is 2x. Line y is equal to x. Then clearly say this is the common portion. Fine. So you can solve this. There is, okay, I can tell you that both way. If I use the dx into dy, what is the limit of the x on the horizontal axis here? What is the limit of this is? On this, x will be y square over 2. Limit of x is, this is my y is equal to x. So x is my y. What is that? Can you find the coordinate of this? It means 2x is x square. So this will be my 2 comma 2. What is the limit of the y is 0 to 2. So I can integrate this with respect to x firstly. So 3 over 2 x square from y square by 2 to y. Fine. So what is that? 3 over 2 is outside. Is 2 to 0 and it is y square minus y4 over 4 over dy. So can you solve this integration again? It's a y cube. Y cube integration will be y4 over 4 minus y raised to power 5. So y raised to power 6 over 6 from 0 to 2. So can you solve this integration? 2 raised to power 4 is 16. 2 raised to power 6 is my 64 over 24. Fine. So it will be my 4. I can divide it by 4 also. So it is a 6, 16. I can divide it by 2. It's a 8. So it is my 3 over 2, 4 minus 8 over 3. So what is that? 12 minus 4 over 3. So the right answer is 2 is my correct answer. Fine. Or if you want to change this as a dy into dx, then again you will get the same answer. I will show you how you can do. Second method is, I can clear this. Now I can change this to be 3xy dy into dx. So for the dy you have to take as a vertical step. What is the value of the y here is x. Value of the y here is root 2x. Fine. So I can integrate with respect to y and outside limit is 0 to 2. Fine. So 0 to 2, 3 is outside. X, what is the integration of the y is y square over 2 from 2x to x. So what is that? 3 over 2 is outside. What is that? It's a x. If you substitute here, it's a 2x minus x square. Now you can integrate this. 3 over 2 outside is a 2x square. So 2x cube over 3 is a x cube, is a x4 over 4 from 0 to 2. So 3 over 2 into 2 into 3, 2 is 8 minus 16 divided by 4. 0 will be 0. So it's a 16 over 3. So 16 is a common. So 12 is the LCM, 1 over 12. So you can see 8, 24, 12, 24 is the 2 is the again right answer. So it's on your choice whether you want to write the dy dx or the dx dy. Okay, D is the closed disk with the center origin radius 2. Fine. Then I can change this into the polar coordinates. What is the polar coordinate? X is equal to r cos theta, y is equal to r sin theta, and dx into dy will be r dr into d theta. So it will be e raised to power minus r square r dr d theta. Radius 0 to 2, angle is 0 to 2 pi. So I can differentiate, integrate with respect to r. So if I take r square is my t, then r dr will be here. So the integration of this will be minus r square over minus half, I can take as a outside. Fine. Now since if I substitute here half, it will be e raised to power minus 4 plus 1, and since it's a constant, so I can say it's a 2 pi minus 0. So it will be cancel out. So the answer is pi times 1 minus e raised to power minus 4. So is there any answer? A is my correct answer of the problem. Okay, look at this another one. Now they are again talking about the transformation. So what is that transformation is? X plus iota y will go to here. This component is my e raised to power x cos y, e raised to power x sin y. Fine. So I can consider it called as this is my u, this is my v. Fine. So then your target will be to find the area of the region S. So what is the meaning of that? Area will be dx, area of the region S. S is my complex. So that means your target is to find the du into dv. How you can find that? Because it is in the terms of the x, I can write in the Jacobian dx into dy. So I can find the Jacobian. Del u by del x, del u by del v, sorry, del u by del y, del v by del x, and del v by del y. So what is that? If I take u with respect to x, it's a ex cos y. If I u with respect to y, it's a minus ex sin y. Ex sin y, ex cos y. So what is that determinant? E raised to power 2x cos square y minus minus plus sin square y. E raised to power 2x my here. So I can substitute here. What is the mode of e raised to power 2x is same into dx dy. What are the limits of this? X is my minus 1 to 2, y is my minus pi by 3 to plus pi by 3. Now since limits are constant, I can integrate both at the same time. This is my x and this is my y. Fine. So what is that? If I use here, it will be my 2 pi over 3 and this will be my e raised to power 4 minus 1 over 2. So this 2 will be cancelled out. Pi over 3, e raised to power 4, sorry, 1 will be e raised to power 2. If I substitute 1, it's a e4 minus e square. E4 is a minus. Where is the mistake? Can you identify where is that? Oh, sorry, x is a minus 1. Lower limit is minus 1. So it is a e raised to power minus. So e raised to power minus 4, e raised to power minus 2, pi over 3. So A is my right answer of the problem. Okay, look at the reason of this again. Can you draw the graph of this? Y is equal to x square. Here, fine. Y is equal to 4x square. It is also the same. Fine. Okay, there are more than the one curve are there. Okay, I can tell you the simple rule for that. You can see if I write y over x square from here, it is 1. From the second case, it is my 4. And this is 1 and 1. So I can use the transformation for so that my calculation becomes easier. I can take y over x square is my u and xy is my v. Fine. So u is my 1, u is my 4, v is my 1, v is my 5. So this, then this integration, what is the y square? You can find the y square also. If I multiply them, what is that? If I multiply them, it will be y square over x is my uv. So this is my uv. This is Jacobian du into dv. Fine. So how you can find the Jacobian? Again, because I transfer from the x to y. So x with respect to u, x with respect to v, y with respect to u, y with respect to v. But here you can see the one way is you can find the value of x and y, but here we have explicitly known as the value of the u and v. So what I can do, I can find the reverse of this. That is, I can find the u with respect to x, u with respect to y, v with respect to x, v with respect to y, and this answer will be reciprocal of this. What is the answer of the u with respect to x? It's a minus 2 over x cube into y. U with respect to y, 1 over x square. V with respect to x, y, v with respect to x is my here. So if I multiply them, 2y over x square minus y over x square. So it will be, so Jacobian is my minus 3y over x square. This is with respect to u and x, but I need a x over v. So this value will be my reciprocal of here. So if I substitute this value here, because of this modulus is a positive x square over 3y. So x square over 3y. Fine. But I need all the terms in the u and v. So I can substitute here. What is the x square over y? U. So this is nothing but is a 1 over 3 u. Fine. Now I can clear screen here. So what is this answer? Is 1 over 3 is outside. Double integration of v du. So what are the limits of the u? 1 is 4. V is my 1 to 5. So again the limits are constant. I can integrate both at the same time. Limits of the v is my 1 to 5 and u is my 1 to 4. So what is the right answer of this? It's a 25 minus 1 over 2 and 4 minus 1. So 4 minus 1, 3 will be cancelled out. 25 minus 2, 24 over 2, that is 12 is my right answer of the problem. Okay, look at this another one. F is a continuous function which is the positive. If the area bounded by fx is from 0 to b, this comes to be here minus of root 3. Where b is belongs to this, then what is the value of the f1? I think it's very simple. If you look about this side, what is the meaning of that? It means my derivative of f, it will be like here. Fine. Then only you can take from 0 to b. If I take from the 0 to b, is a 3 plus b square and here. So once we know this is my f dash, can you find the value of the fx? How you can find the value of the fx? Because this is a derivative, you can integrate with respect to the this is my fx. If this is my fx, so we can we can draw the graph firstly so that we can understand it clearly. So any of the function is here and the limits from x is equal to 0 to x is equal to b. Fine. So this is my portion. Fine. So this has area given to be here. So what does it mean? It means, if I say, it means this is look like say my here from 0 to b. Fine. What does it means? It means if you integrate this function, whatever that, because we target is f1, so my target is to firstly find what is my fx. Once you know fx, you can easily find the value of the f1. So I can see from here. So it means if I integrate it, how you can find the fx? I can differentiate the function irrespective of the limit. So what is my fx? It's a x 2x over 3 plus x square. Fine. So now what is the f1? F1 will be 1 over 4. So that means 1 over 2 is the right answer of this problem. It's an interesting question. You have to look about the function whose integration becomes my here. So that means you can find the derivative. If you take the derivative, this integration will be cancelled out and the integration of this will be my here. Okay, look at this another one. It's a GATE 2023. For some alpha, it comes to be here. Okay, firstly we can draw the graph of this portion. Y is equal to x. This is the line of the y is equal to x. Y is equal to minus x. This is the line of the y is equal to minus x. X is equal to 1. This is the line of the x is 1. X is equal to 4 is my this line. So which one is the shaded portion? This is my shaded portion. Fine. Now he said which is equal to my here. That's the polar coordinate. Once you take the polar coordinate, x is my r cos, y is my r sine. Fine. And this value will be my r square. This value will be my r dr into d theta. So 1 r will be cancelled out. So it is fine. What is the angle limit? You can clearly say this is my, what is the angle of this? It's a minus 45 degree because y is equal to x, angle is my 45 degree. So angle is my here. Now what is the radius? How you can find the radius of this? So it is not an easy target. You can find the radius of here. So what I can do, I can try to solve this integration firstly. I can integrate with respect to r. So it is minus pi over 4. It is ln of r. Fine. It's a alpha secant of this and it's a secant of this. So if I substitute the limit, it is minus pi by 4, 2 plus pi by 4. What is that? It is ln of alpha secant minus, so I can take log m minus n. So this will be cancelled. Ln of alpha, it's a constant value, so it is ln of alpha is outside. It's a pi over 4 plus pi over 4. That means pi over 2 ln of alpha. Fine. So I can try to write this integration also. If it is come to be pi by 2 ln alpha, we can find the value of alpha. What is the integration with respect to y? What is the integration of a square plus x square? It's a tan inverse x. So it's a 1 over x tan inverse y over x from minus x to plus x. Limit is from 1 to 4. What happen is ln x, when you substitute 1x, it is a pi by 4. When you substitute minus x, it's a minus pi by 4. It is my here from 1 to 4. So pi by 2 is outside. It's a ln of x from 1 to 4. Fine. So what is that? It's a ln 4 minus ln 1. ln 1 will be 0. So if you compare both the terms, what is my alpha? Alpha will be my 4 is the right answer. If you are able to find the circle, okay, you can revolve them. If you want to revolve, then again you can find the value of alpha, but you can little bit calculation here. I hope you can like, share and comment on my video too. You can follow this playlist of the GATE mathematics and you can find the various PY questions related to the numerical analysis, vector calculus, Bessel and Legendre function and many more in this playlist. We will see the next lecture on the series solution of the ordinary differential equation. Till now, you can simply like, share and comment on video. Best of luck students. Happy learning.